Hi, Harsha.
Good morning, Mahesh. How are you?
I'm doing great. How are you?
Okay.
Good to see you. Long time. Uh, and your session will be on responsible AI. I need to announce that. Are we on the same page? We can discuss tomorrow details. Is that
Yeah, I already have quite a bit of assets and collateral to for that topic. I've written a white paper, then I've written some diagnostics and assessment toolkits and things like that.
sounds
Um,
like a plan? Let's announce that, right? As people come in.
then I'm trying to adapt some concepts from a book called Radical Product Thinking and Product Diseases. So this Radhika Dutt, she's a mentor. She has introduced this concept of product diseases. So I want to see if I can introduce a new thinking into responsible, AI products.
Sounds great. I'm going live. 3, 2, 1, go live.
But Mahesh, I can schedule the 7 a.m. tomorrow, right? Yeah.
Yes.
I'll monitor the LinkedIn.
Can you hear me all? Hi,
Yes.
Shilan. Hi, Harsha. Hi, Valentine. Hi, Virad. A lot of people are coming in, so I will keep admitting them. That's my full-time job these days. Uh, Joanne is here. Neeraj is here. All good to see you all again, especially people. I think this is like becoming our cohort thing now. Neeraj, you and all. Oh, now Amrita is coming from the cohort that I didn't teach, where I said I will teach, but I didn't.
That's
This-
true.
So, there is more to life than this. But again, welcome to this fantastic Saturday morning. Sun is out there and life is good. Hi, Sridhar. And I think it will be an exciting session today. I prepared some cool stuff around what NVIDIA is doing. I will also talk about AI stack. Shala and Joanne will help me because they have already seen that AI stack. But obviously, I will add flavors to it, make it hard for them. And we'll go through that first. And then what we'll do is we will also do today. I'm introducing an okay time for slides. Everybody had a slide link. No, maybe yes. So today's a packed
No.
session. It will go very, very fast. And hopefully today my goal is you can contribute. So the goal remains that we all learn together and not I learn alone. So that's the goal. And that's why I put up a small exercise for us to do. We will take Porter 5 forces and analyze NVIDIA. So that's the suspense. I'm going to give you the suspense first. And before that, uh, you need to see like how are you doing and learning, and hopefully uh, this will the first part will give you enough material to fill in that workshop, and hopefully we can have a discussion. Even if don't have a discussion, I think I will look at that and all of us can have something to take away with that. I will share my screen with my deck, and we will take it from there. Share my screen. This, not this one. Let's share this one. Can you see me all again in a shared screen now? We good?
Yeah.
Okay. All you see is my study on NVIDIA's, and this is our community. Oh, it's so hard for it to find that now because I opened it in another tab. Okay, maybe I can just pull it from there. I see like how we start and how we end. In the end, everybody's trying to get out so many things, and in the beginning, everybody's like, ah, really? We have all the time in the world. This is how everything starts here, right? Okay, can you see my screen now? Okay,
Yes.
great. Let me just get Rashmi in, Saurabh in, and a couple of more folks in. Can I just say admit all? These AIs, right? I'm just too bad. We'll just take them out because I want to divide you in group and I don't want you to run into like 3 AIs. So we have a good forum. Top of mind for me, I think few logistics things. Slack channel. Uh, we have also done what we have done is we have looked at the forms. Thank you for filling the forms. I'm talking to a couple of my friends. Hopefully, we will open up more. But two people we have got for this month, and then I will obviously put you up for the next month, upcoming months. So that is going on. And what happened in the industry? Databricks, DBRX, 132 billion parameter model, the largest model. Awesome. And beating everybody, including GPT 3.5. So that's the cool part. Wow, today like something happened somewhere. I think all my people from previous cohorts are here. I see Jyotsna here, I see Joanne here, Shlan here, and these are the people who always turn on their cameras as well. So they know the protocol that I like talking to people rather than screens. So thank you for joining Rashmi, Jyotsna. Uh, Good to see you again, and hope you are doing well. You can see I'm doing great. And Vikram is here as well, right? Yeah, Vinod is here. So a lot of cool people today. Okay, coming back. So Databricks new model. I think we should break it down. One of my friends worked there. He was the director of engineering. Now he's VP of Mosaic AI, and then they sold it to Databricks, and he was the core guy whose picture was published. So felt great, and looked at like what they have done. I think they have done some cool stuff. One is that it's a MOE model. We have discussed what is a mixture of experts, basically training a one large big model which does everything. What you do is you go and train experts, which is small models, and then you combine them. And they went with 36, I believe, 36 experts, 16 experts. So Grok and another company, can somebody name another company which is training mixture of experts and making a lot of waves on open
Mixtral.
source? Yeah, Rashmi's such a fan. Mistral. So Mistral, a French company, said, okay, whatever OpenAI is doing, we can actually do it in open source. Llama was not a real mixture of experts. We can train a mixture of experts model. They threw it out there and became super popular, got investment from Microsoft, and now came a couple of months later, now comes Databricks. Uh, does anybody want to talk about Databricks? Anyways, we'll talk about Databricks later. But quickly, context is 32K, 16-bit quantization model is what they're publishing. Cool numbers. I pasted a link here. Please go through this link, has all the details, and we can talk next time. I know you may not have watched this Lex Friedman show yet, but I really want you to watch this show. So please watch the show. Uh, I I would love to discuss that with you one day, but bring your questions because this is like little intense. And if you attended my cohorts, uh, or if you actually followed, you will be able to follow 30-40% of this talk, which is great, by the way, because you're listening to the scientist who build deep learning and who is the VP of research. And if you can make 40% of his talk, I think it's a great accomplishment. I can make like 70%. So just to give you reference, I didn't get all there are a couple of cool ideas there, especially around joint embeddings, which I would like to cover with folks here. So let's read that. Maybe next to next week we can talk about it. And please come on time. I don't like uh, earlier I had this luxury where somebody else was admitting people behind the scenes. Now I don't have that luxury. So so it just diverts. So what are we gonna do today? So cool part is watch this show, read this announcement, and we will bring or discuss them again. And with that, what are we going to do today? We're going to discuss NVIDIA GTC. We will also discuss NVIDIA's position in this world and why I wrote 100-pound gorilla. One of my friends said that should be lean. So it's a 1,000-pound gorilla that's becoming like beating companies like Facebook and getting closer to becoming the largest company ever by uh, market cap. So why is that? What is Nvidia's moat? I will discuss like couple of my mistakes in that space and how I recovered from them, especially how as a product manager you need to make bets on chips and where they work, where they don't. And we'll talk about key takeaways, but I will also give you something exciting, which is five Porter forces analysis, which we'll do together. And hopefully all of you will, we have a big quorum. We have 21 people. I invited 30. Good rate. So thank you for joining again. And we're just getting started. Before I get started on NVIDIA, I want to touch on a couple of things on AI stack. I know I never showed it to even people who got to our cohort. We showed like this, like a pyramid, as if everything was same. Yesterday, I just changed them to make sure that they are looking like how much space they have in the world. And let's go to the slideshow mode because it's even more exciting. Look at that. Now we can even do slides with button clicks and all. Isn't that cool? So next, AI chips, right? And okay, last person I'm making admit today. Chitali, please come early next time. Okay, so we're trying looking at AI stack, how we build AI apps, and what what does it what does it make when we talk about like AI companies, AI product manager jobs, or AI is gonna change this world or do so many cool things? What does this actually means? We're gonna discuss that. And can I just stop sharing my screen for people on LinkedIn? Because last time I got a chance to actually see there are like around 75 people on LinkedIn. So I was like, I don't even talk to them, and I give them a small screen to deal with, and they never see our board. Okay, you guys can see my board, right? Okay, lowest one, AI chips. And I will talk about like product managers, like what you are supposed to do there or not. But can you give me an example of AI chips?
The Blackwell.
Yay, Blackwell. So NVIDIA. NVIDIA is a big player, as I said, the biggest player in this market. Who else is building NVIDIA? Who else is building AI chips?
Google is building TPUs, I believe.
Google is building TPUs. Great, Priyanka.
Then this
And
Grok, Grok
Cerebras.
company, Grok.
Intel is building.
Oh, thank you.
Yeah.
Intel.
AMD is building.
So Intel, AMD,
Grok.
Grok.
What about Cerebras? They are not.
Cerebras. Good answer.
TSMC.
TSMC is not building. I think they all go to TSMC, but yeah, let's put it out there. It's part of the ecosystem.
AWS is also building, I think.
AWS, thank you. Is Microsoft building?
Apple is supposed to build its own custom chips.
Yeah, Apple.
So basically, every company is building an AI chip. Then why is NVIDIA such a cool deal here? Why NVIDIA stock is like 2 trillion worth and not anybody else? Why not Cerebras? Why not AMD?
Early mover advantage, right? They are the pioneers of CPU.
1993 they started, right? And they are pretty good in the hardware in terms of the GPUs and the knowledge of optimization. I mean, Intel is also doing in terms of Onyx and other things, but NVIDIA is like the first mover, I think.
I think in addition to the chips, it's also the supporting optimization and software libraries.
Yeah,
that
the CUDA libraries. Yeah.
that make best use of the hardware designs.
Yeah, pretty good. Somebody said pretty good. So let's. So Brajesh is here now. I can get started. He's so on time right today. Hi Brajesh, thank you for joining us and honoring. This is like I've become a scolding teacher in school, right? There was this scolding teachers in school who used to insult people when they come in late. So I will do that going
I
forward.
guess we'll have to do sit-ups now.
Yeah, I think that's how we should go. Okay, what is the major difference between GPUs and CPUs? GPUs has many cores, small cores, while CPUs has large cores. What is the advantage of having small cores for machine learning? Because you want parallel processing. It's all about matrix multiplication. Y is equal to WX plus B. Who remembers that equation? Y is the output, X is the input, W is the weights, and B is the bias. We discussed that. Somebody say yes, please.
Yes.
Yes.
I spent a whole last year just working on this one equation. At least you got that right, right? So now what this W is basically a matrix, all the weights, how many weights that could be in a large model on a mixture of expert model, even if I break them 36, right? So the advantage of MOE, which we were discussing earlier, which is mixture of experts model, what they do is they break the models into smaller models. So they have their own y is equal to WX plus B, y is equal to WX plus B. And now you can train them parallelly. You want to do parallel processing. The compute is not large, it needs parallel processing. And what they are good at is GPUs are good at that. And why were they good at that? Because NVIDIA built something. What is GPU full form?
Graphic processing unit.
Perfect. It's a graphing processing unit. And a graphing processing unit needs to take care of the whole screen, pixel by pixel. So they built that, always the chip was designed in a way to do small calculations parallelly so that we can increase the refresh rate of your screen. Correct? Harsha, go ahead.
I'm very curious, why is the GPU a separate component from the main processing units? What was the historical need to design a separate GPU for mathematical calculations and offload it to that?
Right? So first they created a graphic processing unit because they saw the CPU was a central architecture for doing all the computation and operating system things, which is an arithmetic operation for running instruction based devices, which is Intel is good at. So you have instructions, which is moving registers and doing multiplications, which is what they do, but they do it at a smaller level so that you can have a higher refresh rate on your screen. So what NVIDIA was doing is saying, oh, you don't need to do, you were watching movies or you are using a computer for doing, mathematical Excel or Word or PowerPoint. You don't need a GPU on your motherboard. You can live happily ever after. You don't need really a big GPU. But you are doing gaming. You are developing software for uh, uh, simulations. Those machines needed a separate hardware, which was the GPU. And that's why the motherboard was built in a two different way. And I needed to talk to two vendors. I talked to Intel for CPU and I talked to NVIDIA for GPUs. And as a motherboard manufacturer, Dell, HP, Lenovo will figure out, or Surface, where I worked on, we will figure out how to combine these chips to build one cohesive unit. Okay?
May I ask a follow-up question, please, Mahesh?
Go ahead.
So I read articles that China is building its own AI chips and trying to steer away from the existing chip design and architecture approach. And they're trying to do something so that they're not dependent at all on the US companies and things. So are they doing something fundamentally different than what has not been done before in terms of what we talked about, like CPUs, GPUs, TPUs, and things?
It's really hard to build like an ecosystem from ground up, but they need to do it out of urgency because they see a world where US will one day just stop supplying them chips. So it's basically a power of negotiation, but I don't see that future coming. I don't know enough about that. So maybe we should get Ankur here, who is our experts in chip designs, and he works in AI chips on Apple. I will ask him to do a session for us, and maybe he can answer your question, Harsha, better than me. But let's come back here, right? So we're discussing why NVIDIA is pretty good, and I'm trying to unbuckle that pretty good thing on, and why only NVIDIA, when we have more than 20 players building chips, is like becoming this 1,000-point gorilla, and everybody's watching NVIDIA more than anybody else when this whole AI revolution or AI things are picking up. Okay. So if that's the question, yeah, what we got is AI things are cool because they can run parallel things. Why they can run parallel things? Because they were designed for graphic processing unit. And now starts the first building block of NVIDIA's moat. So what will happen here is NVIDIA building a graphic unit, nobody's buying it. People who are in gaming or simulations will buy that. There are only like 1% of CPUs computer are getting sold with GPUs in it, as Harsha was talking about, a separate processing unit, and that's NVIDIA. In 2012, what happens is AlexNet, the guy builds AlexNet, which is the first time we discussed deep learning, AI, deep learning based networks started coming with LXNet, and feature engineering and model building both are getting automated. What he does is he creates a framework, because one thing is common between graphics and AI, both need a lot of calculation in parallel. So he said, I'm going to use it for CPU, not CPU, but GPU, because I need to give parallel processing. I need to do parallel processing on this. So he chose not CPU, but GPU. And then he won the competition that year, like yearly competition, where he proved that the LXNet can process images faster and most accurately than any previous network before done. And it was a CNN based network. So, and then you got the model building path was neural networks, and LXNet was born. And once LXNet was born, there was this framework he launched called LX framework or something, which allowed anybody to use NVIDIA cores for AI workloads. And his innovation was nothing but mostly figuring out how can you actually train this model on a larger compute faster with so much data. He was just adding data, because this part was whole automated. You can just add data. So the function became, how can I use the compute with more data? And he provided a framework on top of it. So if you look at our journey of AI stack, the second thing was born, which was you got the chips here, and then people started building frameworks, AI frameworks, AI frameworks, which will allow them to use the chips. And whose chips are they building the frameworks for? NVIDIA's chips. And that went for 2016 till 2012 to 2016, 2018. While everybody was waking up, NVIDIA started building CUDA libraries, integrating into frameworks like PyTorch and TensorFlow or Onyx. And if you use PyTorch and TensorFlow to train your model and you had an NVIDIA chip, all you need to do is change one line of code, and your program will now run on GPU, and it's like 30x faster or 100x faster, which build a developer ecosystem, which is MLOps tooling layer. So now people started building these tools using the framework layer. So the AI chips powers this, everything runs on an AI chip. Frameworks are there to use them. And then there are MLOps tools, which allow you to train and deploy. And all this integration is happening on top of chips. And today, at that time, only one player dominated the market. So everybody built this whole stack on top of them. And then people started offering AI as a service. So you need something to translate. You can take that service from AWS, GCP, or Azure, and they will do all this work for you. You need not to buy AI chips. You need not to build frameworks. You need not to build the whole pipeline of how to train or deploy a model or continuously train a model. You can just take it from them. But behind the scenes, it's same chip that's running. And people are developing on top of it, learning CUDA libraries and the whole researcher ecosystem. And then came the whole LLMs, large language models, which said, you don't need that many AI services. I can actually give you one service and which can become anything. It can do translation, it can do sentiment analysis, it can do graphs for you, it can create images, it can process, it can read, it can write. And when we are creating this, the cool part here is that this becomes an arm race. Everybody wants to build the one operating system like Windows for the large language models, or this world model that we are talking about, a model which can see, a model which can read, a model which can generate images and generate text, and it can train itself. That's the race of AGI. So if you look at why they are pretty good, because these guys don't want to take a risk. The LLM providers, OpenAI of the world, and Mistral, Databricks, AWS, Anthropic, nobody wants to go and reinvent this wheel because the researcher already know how to use NVIDIA's GPU. So if you bring any other GPU here in the bottom, what will happen is you need to hire new researchers and train them for this GPU. And there will be bugs in new GPUs. They will not work. The speed will be slow. Your model launch will delay by 2 months. In 2 months, things changing so fast. Every 2 months, we are getting a new LLM trying to say, I am the best LLM. So time to market is everything when you have an arm race. So if you are a big company, what do you want? NVIDIA GPUs? Why they are pretty good? Because they are the most reliable and everybody knows them. And the tool chain to train a large language model, which is basically not a single GPU, you train it on thousand and thousand of computers, is the most widely available, is the most widely popular amongst the developers, and it's the most, I would say, the fastest cluster of training. It's not maybe the fastest single GPU, but most fastest cluster of GPUs. That's what we will see today. You will see that when NVIDIA is launching their GPUs, they don't talk about Blackwell anymore. They talk about DGX 200. Then they talk about their pod. Then they talk about the cluster. Because it's the game has switched from a single PC GPU where AMD can beat them, but the cluster is where the game is. And that's where they go and rock. Good. We got the idea of AI stack, and now you know why learning AI stack is important. And if somebody's not teaching them, then it's really hard for you to figure out how these puzzles or everything works in this ecosystem. So 5 main things: chips. How to use those chips is frameworks where you will see PyTorch and TensorFlow. Then ML tools, which is MLOps, which is allows you to bring all of this at a production enterprise scale where you can get the hardware, you can ingest a lot of data, you can continuously train, continuously deploy, learn, and grow again. And then you have services. But if you are a small company and you want to be AI, now you can just take an LLM, take an API, and say, hey, why don't you start doing our support like Karna did and get rid of 700 people or so? That's what they claimed. So that's the first time it's possible, and compute is getting generalized. So last time we talked about this, right? That how Facebook was the company or Gmail was the company which actually leveraged the application of storage to everybody or connected humanity to storage or made storage a commodity. These LLMs are making compute commodity of next generation. So next 10 years, it's all about compute. So whoever has the largest bit of compute is going to be or provide the compute, because we have so many use cases and every company needs more compute, every individual need more compute. And I think as a humanity, we will just go 100x in compute. And it's not any kind of compute, it's AI compute. And that's where the excitement for NVIDIA is. Chitali first and then Harsha.
So Mahesh, one question. So far, I didn't get a chance to fine tune any LLM. So, what kind of compute intensive is fine tuning any foundation model, or say, like what you have faced so far?
Oh, that's a good question, right? So we are training our own, like I've tried fine tuning. First of all, it's not as easy as it sounds. It still requires a lot of understanding of AI concepts. And if you're looking at training, depending upon what you are training, right? If you're trying to train a 3.5 GPT kind of model, you're looking at huge cost. You are
Mhm.
looking at one server, which is A100, and it costs, last I checked, it was $3,000 or so a month, and
Mhm.
you can't get hold of it. You need to first buy a quota, which is make a commitment to them. So one aspect is cost. Second aspect is that finding improvements with these new systems like LoRa, QLoRa, which is
Best and
basically,
Laura, they say, right?
yeah, so these are
Yeah.
hacks so that you can actually train by not changing the weights of the original model, but introduce
Yeah.
new adapters which get trained. So but you still need to hold everything in memory. So the cost is really high, and the quality of fine tuning is not where I would say. So what I have seen in industry is, like, I will give you an example, right? So when ChatGPT came out, you remember Bloomberg trained this model on finance data,
Yes,
they
yes,
said finance
yes.
GPT or something,
Yeah,
and then
yeah,
GPT-4 came out and it beat whatever Bloomberg was doing with finance
yeah,
data. So all the
yeah,
money that you're spending in that is going to flush. So unless you have a very sophisticated use case or a very sophisticated data which is not available and you can't do, I won't recommend fine tuning unless you have product market fit. If you are a startup, or if you're a company which is like trying to make use cases, I would rely on common providers unless you have a serious problem. Better invest in RAG, which is retrieval augmented generation, where you provide your
yeah,
documentation, than
yeah.
going to fine tuning. But fine tuning is kind of moat. So I've seen people who have got good funding, they start from scratch. Like, I believe Harvey.ai said that we're going to start from our own model. Nobody has seen their model, but they get to have a lot of attention because of that. So, net, to answer your question, fine tuning is the last thing you want to do with LLMs.
Got
It
it.
does work. There are techniques which can make that possible. It's still very costly, and getting results and sustainable results out of that is not trivial. I will
Got
stop
it.
here.
Sure. Thank you.
Please, you go ahead, and Harsha, I will take your question last today because you get to chat earlier.
Okay, Mahesh, you talked about some of the reasons why NVIDIA is dominant in the space, and you talked about how when you look at a cluster level, NVIDIA dominates competitors in terms of performance, etc. I'm curious, what do you think about in the edge computing space when you're doing inferencing on the edge, right? So when you look at this sort of stack here, right, is there more heterogeneity and opportunity there?
Yeah, no, I think that's where I played a long game. When in 2018, I thought that it will be an edge computing world because I was living in an IoT bubble, and I thought edge will be a great deal. And yes, but the ecosystem, right, becomes a challenge, Chris, or an advantage for NVIDIA there also. So what happens is, let me give you an example, right? So I build a IoT dev kit, which had an AI processor, which we chose deliberately for Qualcomm because we thought it's about energy, and edge devices will need better energy. So we chose Qualcomm. Qualcomm has a much bigger ecosystem on edge. So we went with Qualcomm. And it worked actually. They were beating Jetson, which is NVIDIA's edge platform, on performance, cost, per power consumption, which are all important for edge. But the challenge remains is that where we failed is that you still need to train a model in cloud, then you quantize it to make a smaller form factor and then deploy. Training on edge is almost like not recommended or not a use case. So let's say you train the model in cloud. If you need to train the model in cloud, what are you going to train it on? You're going to train it on NVIDIA. Then you have to still worry about converting into your ecosystem. Somebody said Onyx. So at that point, I came up with this idea of Onyx, and we worked to build whole of Onyx platform. Onyx allows you to train model in one framework, but deploy it across different chipset providers. If it is Onyx, it can run on Intel, Nvidia, and Qualcomm at that time. And now they might have added more. But hold this mess of training a model and then converting it. For me, our biggest challenge was that once we launched that IoT dev kit, there was popular networks. Remember those developers? They were building those networks every day. So at that time, MobileNet was there. YOLO 2 came out, which is you only live once. These are all image processing architectures, and NVIDIA chip didn't support, NVIDIA supported everything because everybody was training on NVIDIA and inferencing on NVIDIA. But for our chip, it was very restrictive. And that means we could only train on one architecture. So if we gave, as a Microsoft, we want to build for every developer because we want it to be used in our cloud. So if you are a developer who is using YOLO model and want to try it on my dev kit now, it doesn't work. And I can't do anything as Microsoft. I need to call Qualcomm. Qualcomm puts me in like 3 months, 6 months backlog. And till that time, what I do? Nothing. So that's the challenge on that. Advantage of getting into edge is that you can actually control a lot of scenarios and run on your control world. For an example, if you are embedding a chip, and if you are Apple and it's your iPhone, and you have a tighter software and you have a tighter software hardware integration, then you need not to worry about new software running, and you can dictate, or you can actually launch a new library like Apple does, uh, which is core ML for them, I believe. And then developer has no choice. So yes, there is a threat, but there's no like price margin advantage there. So that's the biggest. Still, they continue to have the moat because people are not able to get premium pricing on edge chips. Chris, did I answer your question? So yes, it's possible. Yes, it's there. Yes, you will see more and more edge chips out there, which are not NVIDIA chips. But if you look at the margin business of AI chips, it's gonna be in cloud. It's gonna be large, and there people don't want to take risk. They want to be fast, and that's why AI continues to be NVIDIA's dominance.
Yes,
Chris?
thank you.
Priyanka, and then Harsha. And we need to be real quick. I will try to answer quick, and then I need to move on. I want to reach to the crux of this, which is why I'm telling you all this, so that you can do that 5 porter thing today. Priyanka, go ahead.
I'll be super cognizant of time, and my question is not that complex, Mahesh. In perspective of a AI ML product managers, we were talking about AI chips, right? So, as a product manager, what knowledge should you be having of the chips and how they are fabricated or manufactured? How critical is that? I'm kind of curious about that.
Yeah, I think that's a very good question. As an AI product manager, you need not to know about how they are fabricated, what they are made up of. Uh, you need to understand what it takes to build on top of these chips. So you need to have an understanding of frameworks. I didn't had that understanding. This was my first AI based real hardware product. We were thinking about software before that, so we need not to worry about, but I actually built a hardware. And at that time, you need to know what the ecosystem looks like. You need to talk to developers and see what works on what chip and what doesn't. Second thing, you need to know about the power and cost equation, because eventually it comes down to power, and how much power do you have if you're running on edge, and how much power can you afford in your data centers. So if you're working as AI infra, this is important. Let's go one more layer up. If you are a PM who's building services, just know that don't do anything other than NVIDIA. If you are trying to be the top person in that, or you're competing fiercely, and
Yeah,
people are looking for the most accurate AI service,
right.
do not do anything other than NVIDIA, for the same reasons that it will be really, you will be just innovating more on like how to make it work on somebody else's chip, rather than innovating here to come
Right.
up with the most accurate model. So just knowing that is good enough for you. So different layer of the stack you need to know differently. uh, I think that answers your question.
Yes, thank you.
Harsha, sorry to keep you waiting all along.
Oh, no. So I had a similar question to Priyanka, but I'm going to pivot on that. Now, we keep talking about LLMs, but there's also large vision models and there's multimodal AI coming down the line. So keeping that in mind, and new products and services and what AI PMs have to look forward to. So how do we factor this knowledge of AI architecture and AI compute into these multimodal AI vision models, sound models, and things like that?
Yeah, so I think you have to look at, when you go so deep down the line, you have to look at the architecture. What you are seeing is, even with multimodal, the architecture is remaining same. People are going with transformers. If you look at Sora, they are going to use the transformer-based diffusion models. So if till the time the architecture remains same, this is a threat. The real threat, which Chris pointed, is not edge. The real threat to NVIDIA is that people have stopped innovating on the architectures. Remember, in my example, the challenge was YOLO was a different architecture, MobileNet was a different architecture. So the Qualcomm has to adapt to different ones, and who adapt for them? The developers. But if they don't have developers using their libraries, then they. But now, as the world unifies to a transformer architecture, actually the AMDs, Microsoft, AWS, all can actually build chips because they can optimize it for one architecture, which is transformer. And if they optimize it once, they can actually get ROI of that in 10 years. So how I solved that problem is more interesting than for PMs. And that's what you need to do. And that's what these companies are betting. So if it is all NVIDIA game, why 20 companies and why especially cloud providers are spending this money? That lies in the solution to my problem. So remember my problem? I launched a hardware and now people are using it. And once they bring their own model, it doesn't work on my hardware. So they are saying, why I paid you $500 for this hardware? It's useless. So what I said, hey, why worry about? Tell me what you want to do. And they were like, oh, we have a couple of images. We want to label them, click a button and then deploy. I said, I have a service like that. It's called customvision.ai. If you look at, we have done a few sessions on it. Customvision.ai is a Microsoft service which allows you to upload images, tag them, and then click a button, train them. And then we used to give a container which you can run on any hardware, which is the hard part. So I went to that team and I said, let's integrate my Vision AI dev kit into your stuff. So that means now I'm controlling end to end and I can choose one architecture which Qualcomm can support. And now the user is not worrying about the architecture behind it. And I can run all the workloads through my common architecture. And if that problem is solved, nobody cares behind the scenes it's running Qualcomm or not. They actually want to train models, right? And training model means they have data and they want an output. In between, if you can automate end to end, you're good to go. Now, if you look at the large language models, once these open source models become open, even if they are trained with NVIDIA first, what GCP, AWS, and Microsoft can do is they can actually have their own chips in their data centers. They can hire one team which can figure out how to train Llama or inference on Llama using their own chip. And now they have a cost advantage. Now they need not to pay the same for their workloads, right? Their own company workload, like Office is running, Copilot is running. All these AI chips can be their own AI chips. And that's the cost advantage they can offload to their customers. So if you read the strategy of AWS, it's not about Bedrock or SageMaker. It's about Infersia and Trainium as well. They are saying, if we save the cost, we will offload it to you. So come to us. And we will save the cost because once we know what workloads are running, and they're running on a common architecture called Transformer, and we will build Infersia and Trainium on that architecture. We will train faster, inference faster, and we will take care of the developer ecosystem gap for you. So that's a threat. And that's your answer, Harsha, right there, which is that multimodal vision and all. Till the time the base architecture remains same, uh, everybody has a good shot at becoming the next NVIDIA, but not for next 3 years, unless things settle down, because right now everybody wants to move fast.
Right. Thank you so much for the excellent answer. I got the crux of it. The transformer architecture is what we should be cognizant of. Thank you so much.
Perfect. He's like, Mahesh, move on. Okay. What have they announced? They now combined two chips. So now the first time what they have done is they're taking H100, H200 and similar chips. They combined them to create a Blackwell. Blackwell, they have the system called GB200, which will allow them to have a CPU, their Hopper CPU. They are taking some 36 CPUs and 72 GPUs. And now they can run 4 times faster training and 30 times faster inference. Once you take that, that's your PC, that's your one train as server architecture. And then you can put 8 to 32 to 64 to create a rack. And then you can put all these racks to create a whole data center. NVIDIA is NVIDIA not because of the GPU now, because of the interlinks, the NVLink and InfiniBand. If you want to work in AI infra, understand how NVLink and InfiniBand works. Basically, these are the connections. And when you are training a large model, you need to collect these weights from different CPUs, right? And then make an average and then distribute it. That means communication between GPUs is very important, and how they communicate with memory is very important across a cluster. That's where their moat is. InfiniBand is the moat they have. So for an example, 3 years ago, only Azure had InfiniBand, because Azure did not did any research innovation. They said, whatever NVIDIA has, we will copy paste it in our Azure ecosystem. That means they paid the most expensive, they bought the most expensive setup from NVIDIA, but they got InfiniBand. That means they can train large models the fastest. They were the only crowd which can do that. So when OpenAI was looking for a partner, they looked at every cloud provider, and they had a large model to train, which was 175 billion model, GPT-3. They partnered with Azure because their infrastructure was the fastest for a large cluster, not for single GPU, but the cluster. Everybody had the same GPUs, but the cluster is what their advantage is. Beyond that, the big takeaway for me is that NVIDIA has, from the beginning, tried to not become a GPU company in AI space. They have always tried to become an AI foundry. What that means is they say, oh, we don't sell you, we sell you GPUs, but they are for the cloud providers. We also have microservices. We have trained all the models. They're available as containers. Here is our model repo. Here is a service they launched, which was this NIM service, which basically contain everything that you need to run that GPU from the software stack, and you can just port it on any machine and run it. They invented on Omniverse and then started on their robot stuff. With that, Shilan, you have a question?
Yes, actually, I have a question. When I was listening to the NVIDIA GTC talk, right, when they announced the microservice, I was like, interesting. So does that mean NVIDIA also become a competitor for example, like OpenAI or like big creative company, for example, like Adobe's? Because I mean, now people can use their microservices, right, to do whether it's like work that was done by LLM or text to image, those sort of stuff. But or you think that those microservices, they're just doing it for like a demo purpose? So I'm curious. Yeah.
But yeah, so once you become, right, once you have such a cool advantage right here, right, what you want to do is, am I sharing my screen? No, maybe. Okay, not really, right? Let me share my screen. Okay. So when you become, hardware is no more your advantage because people can compare you with AMD and won't value you. You want everything. What you want is, you want to be the data center, the only data center company with CPU and GPUs and the whole integrated circuit, which is what GB200 is. Once you get the hardware, you want to get to the microservice layer. And once you get to the microservice layer, which is you are offering services, you want to build a whole cloud for AI, which is what they are trying to build and provide services. If you remember, Jensen talks about how Snowflake is using them, how NetApp is using them. So they are saying, we will provide end-to-end services for AI. If you are doing AI, we will provide you how to host data, how to process data, and all. So yes, Shilan, your observation is right, that they are trying to compete with everybody at some point, while basically selling to everybody at the same time, right? And that's where the thing is, that if you're looking at a world where all the assistants are talking to assistants. So remember, like, all of us will get assistant, AI assistant, and they will decide for us what is good, what is bad. Then we are looking for compute, and if they can run the compute and they can know how to build these assistants, which are hopefully the robots of the future, and if they can take on that ecosystem, they will be the company that, Google, Facebook was in 2000. And that's the bet the whole Wall Street is making now. So you read it better than me, I did, so good job. So what does this means, right? The use cases, what they this GTC 2024 provides, it provides that model like ChatGPT. It was taking them for a year to train a 1.8 trillion parameter model. If they want to train the same GPT-4 model, actually they can make 4 releases in a year. Imagine, like, GPT-4, what it does in a year. Now you can have 4 times that. That's the training speed. Another thing that's happening is that with this new chip, you can actually now serve 30 more customers if you bought those chips in your cloud. So you're looking for cheaper and cheaper prices of compute, because if I got the system and now I can handle 30 times more inference, which is generation of words or emails, then I will subsidize it to have more and more people on my platform, which is why you saw GCP is buying them, AWS is buying them, even if they have their own chips, because they are providing the fastest running, latest models. And now every year they are coming with faster and faster speed. And then second thing, the most important thing was they're reducing the memory, the power footprint to 1/4. So 1/4 power in a data center, 30 times more customers you can serve. So imagine, right, the cost of doing generation of images, text, writing emails, doing marketing calls, or summarizing contracts is going to go 30x lower at least. That's what baseline is possible, right? On top of that, they can have their margins, but that's what I am looking at. Also, they showed that they can actually process 4x more data. So a lot of work before you train a model is actually combining the data, doing joint operation on data. And that actually is like going to be 4x faster. And the last thing they said is that they are making uh, visualization or creating these simulations for 13 times better. That means things like metaverse, things like app for Apple Vision Pro can be built or run 30 times faster. So we are entering this new world of GPUs, powered visual simulations and simulation worlds. So gaming, new apps in new immersive worlds like metaverse are getting power from the chips now. They also try to become an omniverse company. So whenever I look at this session, this GTC, for me, the big deal always is that what is going to happen in the industry next. Because if you see that they were doing grapher processing unit, then they said they can do crypto mining, then they said they can do AI. And if you look at the GTC 2024, I think three things that the next thing they are betting on is or the everybody, because if whatever I want, and if there is a use case for it, I want a chip for it, and today I go to NVIDIA for that, and NVIDIA listens to that and try to show in GTC 2024 what are they building for next. So I think this whole understanding of AI and physics environmental understanding through robots is going to be possible, or at least a lot of investment will go in that area. That's why you saw their whole framework for building robotics and simulations and their gym for training these in Omniverse. Second is the simulations. I think the whole idea of creating virtual worlds and simulating them for enterprise as well as for consumer is going to see a rapid progress in next 5 years. And other than that, I don't know what next. These are the two I can see where AI will actually play a major foundation role, but the use cases will be we will have robots doing more and more, and we will have simulated worlds before we actually start building real world to do reducing compute or energy or money needed. That's the world. That was my takeaway from GTC 2024. Now, I want to spend 5 minutes with all of you to do this, which is if you got this link. If not, I'm going to paste it here. And this is what we will do. Can you guys extend for 5 minutes? Because everybody came late. You can blame Brijesh for it. He made it possible. You all should blame Brijesh, but let's stay 5 more minutes. I'm going to break you into five teams. And if you are team one, you're looking at threat of new entrants to NVIDIA business. So we talk a lot about NVIDIA. We talk a lot about chip. You now know what the stack is. You know what their advantage, disadvantage is, little bit at least. And I want you to come up with your own insights. What are the evidence you have seen? And what could be the potential impact on NVIDIA of that?
Can you send a link, Amish?
Of course, it's part of this community session. And here is the link. Thank you for reminding. And can Harsha do it faster than me? Let's play the game. Priyanka beats both of us. Okay, then you have the link. Please go here. I'm going to divide you into five groups. If you are group one, you're filling this. Take 5 minutes to discuss. Just jot down like points, and I will see you back at 10. And then we will at least go through top of these in 5 minutes, and then we'll conclude the session. Does that sound good? Valentina is like, I don't get what you are asking, Mahesh, but let me go to my group, talk to my colleagues or my friends, which I will make in this call, and then I will come back to you. Maybe take 10 if you want. If you want to leave, you can leave now. That's okay. I won't be hurt. But I think it would be fun. I can stay back today. Shilan, we can move our meeting. That's the only thing we're going to lose today. But I think this is important and would be fun. So next step, I'm going to break you into 5 teams, a group of 5. Please talk to your friends. If you're group 1, you're discussing threats of new entrants. What does it mean? What that is? What are your insights for NVIDIA? Uh, Describe them, put some evidence, 3 description points, 3 evidence point, and what could be the impact of NVIDIA. Do the same for second, third, and fourth, fifth. And I will see you again here in 5 minutes, Joanne. Good? I forgot how to do that. Breakout rooms, I got it. Assign, create breakout room, 1, 2, 3, 4, 5. Assign automatically, create. Awesome. If you get a Firefly bot in yours or some bot, we will do something about that one day. Right now, just go. Bye. See you in 5 minutes, okay? 10 minutes at 10:05. Open all rooms. I will be here if you have any questions. Or get a glass of water and then I will be here. You guys got the rooms? Yes. Awesome. Hi, Saurabh. Long time. Welcome back. I think this is the new thing we tried today.
So nice.
We keep adding new things. You can't hear me? You can hear me. Valentine?
Yeah,
Yes.
I can hear.
Yeah, I think we keep adding new things every time. I think we started with me just talking, then we said me talking with slides, then we said me talking with the doc. And today, what we tried is me not talking that much, and you are actually going and doing things with people like
Still, you
you.
ended up talking.
Sorry.
Still, you ended up talking.
Yeah, see, Rashmi, see, still I ended up talking a lot, right? But we bring a format in and then we try to adapt to that format. But I was looking at all the insights you shared. I have shared mine on how I will do key insight one. If you were doing key insight one, please feel free to delete them. I was just thinking with all of you folks. And the idea is that if you look at like this company comes out to be a very strong force in that world, and I can stay back if you want to take like 2 minutes each from one person from each insight, and would love to get past this. But if you want to drop, you can drop now, or we can stay 10 minutes. It will be five things, 2 minutes each, 1 minute each. Let's do it. Key insights, threats for new entrants. Nobody's leaving today. Like I had 35 people, now I had 37. Seems like people are just joining for this. Okay. So key insights, threats of new entrant. Who want to talk about that? Who was there? I was looking.
So I can try, but it's really combined inputs, right? With
Yeah.
Rashmi and then
Of
Sarob
course, everybody was there. Just
and yeah, and his friends. So basically for us, right? We thought there are like two bowl. One is for Cerebras because their chipset, right, is smaller. Unlike NVIDIA, it was like giant chipset. And Cerebras, they don't have to like break it down, so the throughput will be better, and they can. I think the advantage is support like smaller models. So their target market could be right, like at the new and up and coming startup or small and medium size of business, which NVIDIA, I think their focus is more on like, the giant computing powers for the really like big five, like big corps, right? And then and other thing that we were thinking is actually that is from your cohort, because we talk about like Qualcomm, like AMD missed the boat, right? But then, I mean, the new AI models is always evolving, and there will be like the next LLM, the next transformer architectures that potentially need some new ways of new operations of compute, right? Like maybe, that there were like a next value functions that has become like important in the metrics operations. So if company like Qualcomm or AMD can caught on, then they could be, a threat to NVIDIA. So that's our thinking. Saurabh confirmed my observations because he is a student, so he actually know the latest of what's going on there.
We can hear you, Mahesh.
Mahesh, you're on mute.
You're not on mute, but we can hear you.
this is just the world telling me to not speak too much. Okay, we are back. I think the key thought here is that you brought a couple of new things, which was one is this idea that what if a new architecture comes, and what if the new architecture comes from a company like OpenAI, and before they release the architecture, they actually buy the chips, build the chips, and release the whole ecosystem with it. That's, I think, is a threat of a new entrant, which is very distinct, but that could be a real threat because they can threaten the whole thing, because Apple can threaten Intel with their own chips. If OpenAI becomes this one AGI company, and if they have a chip, then the developer will be forced to use or learn their chip, which is not coming in short term but remains a larger threat. And for that, you suggested that they have to focus on emerging architectures and continue to innovate. If they do that, plus one from my side. Uh, I think number two team was pretty strong. I was looking at who was there in that room. You guys didn't fight, right? You folks, number two. So I didn't even touch your section. I was like, let them come up. they will give better insight.
Question, Mahesh. Why don't you feel Cerebras is a very strong threat to NVIDIA?
I think Cerebras is a threat. Cerebras had this. I always actually I talked to them uh, when I was at Facebook,
Yeah.
and their threat is basically Cerebras has this whole idea that you don't like uh, uh, what NVIDIA is doing now, which is basically combining two chips and creating a big
Correct.
wafer. They said we actually never cut the wafer, and we will have multiple GPUs, and we'll do that. The challenge with Cerebras is that, again, this whole idea that if there is no new architecture, if there is a single architecture and everybody's just going to leverage that, the most of the money in this world is going to come from cloud service providers, because they don't want to be short in supplies. Integrate new server with the new technology, new cooling. If you look at like Cerebras, their cooling looked weird to me. And if you don't have that, you don't have a data center use case. Nobody's going to redesign their data centers for Cerebras specific things. Even you look in NVIDIA announcements, they are saying whatever infrastructure you build for H100 will copy paste to Blackwell, so that you
Mhm.
need not to reinvent the supporting ecosystem that you need to build to scale
Mhm.
or start delivering or making a return on your investments. So Cerebras is good for research. They really need to prove that they have adoption, and
Yeah.
by the time they will prove that, I think means I don't see like a speed advantage.
But
NVIDIA
there
actually
is,
needs to just
because
continue to crush that.
recently when I met them, okay, their whole pitch was, in fact, some of the models in my side is trained on Cerebras. Okay, is that, look, whatever takes in 100 GPUs 30 days in Cerebras with their new chip, because I do not have to break the model. Okay,
Mhm.
it takes 1 day.
Yeah, but you need to write that custom tooling, right? They
Mm.
You need to use their custom tooling. You have to learn their library, and yes, you can learn it. You can teach it to one company because that company is a research lab, but who else?
Mm. Got
Right?
it.
So
So
that
that's what
remains
you're
your
telling
biggest
me.
challenge.
Mhm.
And OpenAI researchers are not interested in learning Cerebras ecosystem at this point, or
Mm.
neither does my Google. So if we don't move or big players don't move, then selling it to smaller research lab is okay for them, because they don't have like today access to this hardware and they have budget. So they will do a good job, but I will buy them for an IP, and I don't see that wafer scale engine IP yet. Means
Got it.
just copy paste, right? For them, it's exactly what, if you look at like Blackwell is a precursor to a single wafer scale engine, right? That's what he did, right? He copy pasted them. That's what he does. Like Jensen and team do. They just look at what is going to work and then copy paste it. So people will not have that advantage. So Blackwell is basically, you can think of in less 32 GPU wafer, it's a 2 GPU wafer. Next time they can expand it to 4 and 16, and then what else Cerebras has in their platform. That's my take.
Got it.
But happy to take another
That's interesting.
copy of that. That's why at that time I was like, maybe not. And I think I made the right call. I'm happy. So, Harsha, go ahead.
I'm curious, the energy requirements of AI chips and AI infrastructure, and also Moore's law, right? So Moore's law for chip design. How will that play into the overall forces that affect the market leaders like NVIDIA? So, um, can we say that we have an infinite source of energy to run these huge AI data centers, and heat and other things will? I'm just curious where this consideration will fit in what category of the five forces thing.
Yeah, no, I think that's the one threat that can happen, because they are still going with transistors. And that I wanted to see coming out from you, which is there is this company called Lightspeed, which is basically using light to do calculations. And if you do light to do calculations, you can do it at a very fraction of energy footprint than what today's transistor need, because the transistor need to store the charge and discharge it to give the signals. If you use light, you need not to do that. That's why they got 150 million in funding. Google is funding them. Google Ventures is funding them, like other companies. But that remains a threat. You're right. And what my view of energy and Moore's law, I think energy is top of mind for everybody. And that's why if you look at the biggest deal they are saying is it's 1/4 of energy, because now I need to run more compute, which I can, but I cannot just increase my energy budget in a data center if I am a CSP or a cloud provider. So energy remains the North Star for every chip provider. And new technologies here, what Luminous, Lightspeed are doing, can be real threats. But other than that, I don't see anything.
Is that what I call optical computing? Is
Correct.
that okay?
Look at what Lightspeed is doing. Nick is their CEO. He's an MIT guy, and doing, at least trying to say that it works. But it takes a lot of time to build these things, like 3 years to build a chip, 3 years to actually build an ecosystem around it. So the moat remains 6 years ahead, and a lot to be proven in that yet. Next one, bargaining power of buyers.
I think we didn't talk about bargaining power of suppliers.
Oh, sorry. Go ahead.
I'll quickly summarize because I have to go. And my team had Harsha, Aarti, Chaitali, and Joanne. So here we discussed that the raw materials and manufacturers availability is one of the suppliers, and that is very important for NVIDIA. So they are kind of relying on that. However, and we know historically companies like these have contracts with manufacturers. So they usually want to have such recurring contracts, and the manufacturers have specialized people or specialized equipment to deliver this. So in that way, we think that the bargaining power of suppliers could be low because it's a win-win situation here. And so NVIDIA could have a bargaining power. But also I would invite my peers to say any points that I missed, because I also realized we didn't take down good notes in this document.
I would like to add a couple of things and then you can add. I think what I wanted to see is bargaining power of supplier is that if you look at the suppliers, they are all either Taiwanese based companies or Chinese based companies. So manufacturer happen either in China or Taiwan. And if you look at the political ecosystem today, remains a real threat to their business. It might happen what happened to Apple, which is they have orders, they have competition, but they can't deliver. And that remains a big challenge for bargaining power of suppliers, but actually the bargaining power of the countries at this point, because
Yeah, that's right. We were actually discussing this point in depth, and we didn't put that here, but yes, the geopolitics is something of great significance in this.
and that's why you see, right, that whole incentives in US to build your chips in home, or then you see these incentives for every country to have a subsidiary. And then you look at alternatives that even the central banks are financing beyond China and Taiwan, around how can we build chips across the globe so we don't have supply chain limitations. I think TSMC uh, will have a huge bargaining power and will continue to grow, right? That's another thing you can think of. Like, they are the only provider, and if compute is the new currency, then chips is the new processors. Uh, if compute is the new currency, then chips is the new cars, or you can say, what was there like in earlier, like the fiber networks of the world when we were digitizing the world, like internet.
Sips is the new petrol.
Yeah,
Yeah.
new oil, and whoever controls that, you will see OPEC like things here, which is like they will supply and they will decide when to lower the lower the production of chips, and whoever controls that will control economies. That's how I see it. uh, and that should come out in this one, if nobody has anything else.
Just what I was this very quick point is we discussed about doing a pestle analysis along with this 5 forces, especially for the supplier thing. That's where the geopolitical thing comes. And just to reiterate, the raw material supply of lithium, silicon, and other things which are very crucial to making these chips. Now, the closest lithium source for North America is in South America, right? And the closest for China is in Africa. And so there are so many forces around that. So if you don't have the raw materials coming in, then even if you have excellent chip design, then we can't do it. So even TSMC cannot do it. So it's a threat. So that's why we listed that. But I think it'll come under pestle. So I love to do this pestle analysis and this SWOT thing later in my own time and then share with the group. And
Yeah. Please publish. This is like all single line here is a LinkedIn post. So you should have 500 LinkedIn post on just this paper. There is a lot of going on in these dot points or single sentences here. The next thing I want to bring here on number 2 again is this idea, because once you brought it, it came along, is that this idea that the challenge will be power, like energy. And the next would be like, how can we have batteries which can store infinite energy? And if we can have that, then chips will be like, right now we are discarding the chips which are cheaper and takes more power. But imagine if we had infinite power, and if we had batteries which can store all sun energy, which is dumped on earth every day and can store it infinitely, then we would look like a very different species. So think about that. I think a lot of innovation is going to go into how can we have better batteries which can store longer energy and power these chips. Number 3, bargaining power of buyers. Who are the buyers for their chips? Who is buying NVIDIA chips? First, let's talk about that, and then please tell us what you think.
All the cloud.
Everyone.
They have not decided who is going to talk today.
I'll just say my piece real quick. I mean, in terms of who's buying these chips, the LLM providers are, right? Like the cloud service providers are the main buyers of these chips. They're setting up their infrastructure right now, hopefully to make money in the future. And that's why I added a couple of bullet points in terms of we as a team feel that they don't have much of a bargaining power at this point. NVIDIA owns the lion's share of this market, and they were the first into the market. They have the most reliable, fast chips. They have CUDA on top of it, where all these guys have spent a lot of time and money integrating with. So in terms of anybody else coming into the market, they have a huge moat to climb over if they have to beat NVIDIA. So I think you made this point as well, Mahesh, in the beginning of the call. You said, like, at least for the next 3 to 4 years, much competition going to be. And unless the transformer-based standardization happens, NVIDIA is always going to have that extreme advantage over the others in terms of owning this market.
Yeah, I think one company which can actually bargain with them is Google, I think. Why? Because they have this whole stack. If you look at the whole AI stack, they offer an LLM called Gemini. They offer AI services through GCP. They have a framework like TensorFlow and JAX, and they have their own AI chip. So instead of OpenAI, if Gemini was the model for the world, if that becomes in a year, then NVIDIA will need to learn how JAX and these frameworks, so they can actually say, oh, you're going to block us here, we're going to block you here. So a special pricing first, and then if they become, but we'll see how that went, how that goes. But I completely agree with your analysis. And I think very good points here, which is even I could come up with. So good job, team. And next time, yeah, let's do this, right? Like how they did it. Just put your names so we can talk about that. Like I know who you are. Key insights, threat of substitute product or services. Let's talk more about other than chips, right? Let's talk here more about what they're trying to become, which is they're trying to become an AI company, an AI foundry, AI services company. What the substitute in that product or services, right? AMD, Intel, yeah. Go ahead, please.
So,
Very good notes, by the way.
thank you. So Mahesh, really quickly, will summarize what we talked. So we talked about like there are companies, obviously the other companies, right? AMD, Intel, Cerebras, they are getting into the AI chips market, and that is potentially threat to NVIDIA's products and services. However, we also thought that NVIDIA still is pretty strong in the current market. But in future, they would still have to innovate quite a lot. um, One point we discussed was that a lot of new startups and new companies that are booming might not necessarily have to rely on NVIDIA because of other companies they could potentially get into their ecosystem. So that was another point that we talked about. Um, the production capacity from the other chips, I'm not sure if that makes sense here. But quantum computing was one that potentially could be a threat for NVIDIA. Another one was cloud computing, as more and more companies are adopting less hardware based services, which is NVIDIA's stuff. Um, so
Yeah,
our
I think couple of things here. I think beyond what you brought, Priyanka.
yes.
One is uh, you are bringing this good point that if quantum becomes the compute engine, NVIDIA is gone, right? It would be
Not completely gone. I think it would still take time to penetrate, but it could be a
yeah,
potential
it's
substitute
level.
for market.
It will
The market share.
equalizer, right? It will be an equalizer because they don't have like specific for qubits and processing them. The developer ecosystem needs to be built for it, and maybe there will be a chance for others to get a leap in that world. That's a good point.
Um, One point we discussed was that maybe it would be a good idea for NVIDIA to start diversificate into other industries like making like car manufacturing or providing their services there, just to
Yeah,
get
they
that.
do, right? They have a platform for cars. Nobody's buying them. That's why they are not talking about it. That's the challenge. But eventually, like a car is basically a running computer. What you run in your cloud data center rack, you basically put the similar processor down on your car, and it needs. That's what their Jetson platform is, and they continue to evolve that. So I think good insights. Thank you for
Question
putting
for
the
you,
report.
Mahesh.
I will
So
read it.
as new algorithms and as software development and software optimization is happening, do you think that could be I don't think it's a huge threat, but that could somewhat reduce their market share and could be a potential substitute as well, because that would mean that they don't have to rely on specialized hardware like NVIDIA's GPUs,
Hmm. Yeah,
if that counts.
yeah, definitely counts.
I have a question for
The
you,
last
Mahesh.
one, I don't have see a lot. Just want to touch on it before we call it. It's 10:30. I really don't want to be respectful if you guys are liking the session, but just want to close this today. And existing competitors, who are the existing competitors? That's the question. Who is competing with them?
AMD is a competitor, right? Like, are we talking specifically chips, and
I'm
or
talking about key insights, rivalry among our existing competitors.
Yeah, so I saw that Google, Qualcomm, and Intel formed their own union, right, called UXL. So I think that's probably the biggest threat is can you get enough incumbents that are trying to make a different model and a competing software, kind of like the same way Apple had, you know, Microsoft, right? So now maybe you have two big um, libraries and two big moats that are completely different from each other. So I think that's like one of the biggest threats. And I think in terms of AMD, right, their chips are selling for like a fraction of what NVIDIA's are selling for, right? So I think that's the other thing is if NVIDIA can't push the chips out fast enough, then someone might have to take a lower grade chip. So that's why they're really dependent on their supply chain too.
Yeah, no, absolutely. I agree. And that remains a big deal for them. because here, right, rivalry among existing competitors. The challenge is that they're already competing. Like if you look at who is competing with them, AWS is building their chip, Google has their chip, but they don't want to talk to each other because they have the much bigger fish to fry, which is the cloud business. So they are like, okay, you take whatever NVIDIA needs to take, and that remains to be seen if that's going to change. I don't see that coming. With that, I want to conclude today. I think for summary, right? Please watch GTC. If you have not watched it already, read about it. Now you have a lot of context. Do that. Somebody posted SEC filing or the 10K report of NVIDIA. Read that. Make your own opinion. Make your own opinion on three things, which is what you need to do to build right cost products today and tomorrow for AI. What the cost structure will look like, given the compute is getting 10x faster and 10x cheaper every year at least. And then see like how the new models are building things, how hard it is to monetize AI services when a lot of things are getting into open source. That's the another thing to think about. And the last thing I want you to take away or think about this whole proposal is, what are the new use cases that will come, and how are you positioning yourself, and then apply for NVIDIA. If you need help, let me know.
New use cases in terms of, do you mind expanding on that?
Yeah, definitely, right. So the new use cases, like we talked about, which is these three new industries that NVIDIA signals, which is how can we have mind of AI and the robotics work that humanity has done? How can we combine them? How can we create more virtual worlds with AR, VR, with now AI, which is hard to create earlier, but how can we bring that together? And the third use case is that how can we have compute everywhere? Imagine a world where compute is talking to compute, no more websites, no more search, but a world where you have assistant who talks to assistant, APIs are talking to APIs to get the jobs done. In that world, where you will play, and what will be left for product managers to do? Rashmi entered a waiting room. Okay, bye team. Take care. I
Hey,
will have
this
another.
slide shared, the community session slides, they're shared with the group.
Yeah, they are shared. They're shared with everyone. I will paste the link again. So if you don't have them, please have them.
Yeah.
Here you go. Or we should just paste them in the beginning. Okay, team. Bye. Take care. Thank you.
Thank you, everyone. I
See you
love the
next
session.
Saturday.
Ciao.
Everyone.
Bye.